Foundations of Amateur Radio. The other day, during a radio playdate, highly recommended activity, getting together with friends, playing radio, seeing what you can learn, we were set up in a park to do some testing. The idea was an extension on something that I've spoken about previously, using WSPR, Weak Signal Propagation Reporter, to test the capabilities of your station. If you're not familiar with WSPR, it's a tool that uses your radio to receive digital signals from WSPR beacons across the radio spectrum. Your station receives a signal, decodes it, and then reports what it heard to a central database. The same software can also be used to turn your station into a beacon, but in our case all we wanted was to receive. If you leave the software running for a while, you can hear stations across many bands all over the globe. You'll be able to learn what signal levels you can hear, in which direction, and determine if there are any directions or bands that you can receive better than any other. We set up this tool in a park, using a laptop, a wire antenna, and a radio running off a battery. In and of itself, this is not particularly remarkable. It's something that has been done on a regular basis all over the globe, and it's something that I've been doing on and off for a few years. What made this adventure different is that we were set up portable about 1 kilometre up the road from the shack, whilst leaving the main WSPR receiver running with a permanent antenna. This gave us 2 parallel streams of data from 2 receivers under our control, using different antennas in slightly different conditions within the same grid square, for the purpose of directly comparing the data between the two. Over a couple of hours of data gathering, we decoded 186 digital signals, pretty much evenly split between the 2 receivers. More importantly, the stations we heard were the same stations at the same time, which gave us the ability to compare the 2 decoded signals to each other. One of the aspects of using WSPR is that it decodes the information sent by a beacon. That information contains the transmitter power, the grid locator, and the call sign. After the signal is decoded, the software calculates what the signal-to-noise ratio was of the information and records that, additionally giving you a distance and direction for each beacon for that particular transmission. I created a chart that showed what the difference was between the 2, plotted against the direction in which we heard the decode. That means that you can compare which antenna can hear what in which direction in direct comparison against the other. In telling this story, another friend pointed out that the same technique could be used to compare a horizontal versus a vertical antenna, even compare multiple bands at the same time. It looks like I might have to go and get myself a few more RTL SDR dongles to do some more testing. If you don't have a spare device, there's also the option of comparing other WSPR stations that share a local grid square, so you can see what other people near you can hear and, if you like, use it as an opportunity to investigate what antenna system they're using. WSPR is a very interesting tool, and putting it to use for more than just listening to a band is something that I'd recommend you consider. I've already created a standalone Raspberry Pi project, which you can download from GitHub if you're itching to get started. Thank you to Randall, Victor Kilo 6 Whiskey Romeo, for continuing to play, and to Colin, Victor Kilo 6 Foxtrot India Tango November, for expanding on an already excellent idea. If you would like to get in touch, please do. CQ at vk6flab.com is my address. I'm Ono, Victor Kilo 6 Foxtrot Lima Alpha Bravo.